I mentioned appending to a file. So when you open a file, an output file, if there's already a file that exists in that directory by that name, that file will get wiped out and replaced by the new file that you're creating, unless you open that file for append or something similar. But the simplest way is to open it for append. And the way that we do that is by adding a second argument to our open function with the append constant, ios::app. So basically what happens is we open a file, and then since you're doing append, it's expecting the file to be there. I believe that it will still create one if it doesn't exist. Yeah, it says in the text. It will create one anyway if it doesn't exist. But if it does exist, it will open that file and position your output at the end of the existing data, so that new data that you write now will go after anything that was already in the file. Another thing you can do that will be useful is you can get data. In this case, they get it from a user to use as your file name. A file name is expected to be what's called a C string. I know we haven't covered C strings yet. But basically, it's a special type of character array. And so in this example program, they've created a 16-character array. And because of the way C strings work, that means you can 16 characters of text in it. They input that data from the user and then use that as the file name that they're going to open. And obviously, if you were writing a more sophisticated program using windowing and so forth, you would get that data, massage it in whatever way you needed to, maybe add a path to the beginning of it, and then use it as the file name in the open function. You do need to be careful if you try to use a C string at this point, because since we haven't talked about it, there's some serious limitations and qualifications. We will be going over them later. So if you were to use it now, you would want to stick pretty closely to what this sample program does. Formatting data. Since a output file stream is related to our cout, standard output stream, we can do all the same formatting to that file output stream that we could to our cout stream. For example, we can use what we called our magic formula before, setf iOS fixed, setf iOS show point, and precision on an output file stream. And on page 327, they show you a table with some of those special flags and so forth. Setf, for example, allows you to set a number of different flags. And that, in fact, is what setf means, set flag for output. So fixed means we're going to use fixed point notation rather than E notation. It's the opposite of scientific. Scientific notation, scientific means that we're going to use that E notation. If you don't set either of those, then the system will decide, which is why you sometimes get numbers that look familiar, and sometimes we get E notation, and sometimes it doesn't make too much sense which we get. And we also have set pos, which allows, which means that a plus sign is output if there's a positive value. Right and left for justification, and right is set by default. You notice none of the others are set by default. In addition to setf, allowing us to set various flags in our output, there are some special kind of functions that are called manipulator functions. And those are functions that can be called in the middle of an output data stream to affect how it works. And I know that is all a little unclear, so we're going to look at display 6.6 on page 333 to demonstrate that. So ordinarily, given what we know so far, if you wanted to set the width that a data item was displayed to the screen in, you would use the setf. I'm sorry, you would use the width function with the stream that you needed it to go with. Problem with that is that needs to be a separate thing for each width that we're setting. It doesn't remember it from one width or from one output to the next. So they give us this setW manipulator function, that can set the width of the next element that follows it in the output stream. And it works with any output stream, either the system output cout or a file output stream. So in this program, basically they're trying to take a bunch of input data pieces and make them pretty and line up in a certain way. So they take the input in the box in the middle of the screen on page 334. That says raw data. And they output it as a neatly aligned by decimal point column of data that all looks behaved. So, Hargrove, number 12 on page 330, what output will be produced by those lines of code?
Asterisk, space, 1, 2, 3. Asterisk, 1, 2, 3, asterisk. Next line, asterisk, space, 1, 2, 3. And the last line, asterisk, 1, 2, 3, asterisk.
All right, so I only see 2 lines of output. Asterisk, space, 1, 2, 3. Asterisk, 1, 2, 3. Asterisk, and then a new line.
Okay,
And then an asterisk, space, 1, 2, 3, asterisk, 1, 2, 3, asterisk, and a new line. And the only difference is we had to put in a separate line to set the width for this value the first time. And in the second case, we were able to use the inline manipulator function to set the width, which only works for the very next value. All right, Mr. Nelson, how about number 13? What's going to be output by that?
Asterisk, space, 1, 2, 3. Another asterisk. Space, 1, 2, 3.
So you're telling me this line doesn't do anything?
that a new line?
Set F iOS left. What does that mean? What did that table tell us that meant?
This is going to be justified to the left.
It's going to be justified to the left, which means
It's going to be 1, 2, 3 space.
1, 2, 3 space space. All right. And then we set justification back to the right. Another asterisk. And space, space, 1, 2, 3, asterisk, right? So if we're left justifying, we get the data first and then the spaces. If we're right justifying, we get the spaces first and then the data. And the default is right justification.
Being a set of iOS left, there's not an iOS right after that. It will stay just.
It will stay left until we tell it right. Or vice versa. Width is the only one that is not persistent. Mr. Rahim, number 18. So we have some code for a self-test program. And we want to change it, instead of reading from an infile.dat and sending to outfile.dat, we still want it to read from infile.dat, but we want it to output to the screen. What would we need to change in order to do that?
Delete the outstream.
All right, so you're talking about this line here?
Yeah.
All right, what else?
Delete open.
On the outstream, I'm assuming.
I believe you delete all of the outstream.
All right. But if we delete this, now what happens?
Now, the outstream by itself will not be deleted. You delete that one, right?
You just need to change it to CL and include include IOStream.
If we change this out stream to C out, that's going to send the output to the screen instead of some file. And technically, if we include FStream, we don't need IOStream, but it doesn't hurt to include IOStream as well.
Is C out and F stream?
Yeah. So if we don't include IOStream, it will still work, but it's okay to go ahead and include IOStream. It won't cause any problems. So we talked when we were discussing limiting loops about running out of data. And now that we have files, we actually can run out of data because eventually we'll read the entire file and we'll get to the end and there won't be any data left. So we're going to learn how to test for the end of a file. We're going to do it in a program that that uses file streams, input file streams and output file streams as formal parameters. So we can have a stream as an argument to a function. But what we're going to need to do is open those streams before we pass them to the function so that the function can do whatever it wants to do with them. You'll also notice that they put the using namespace std up at the top. The same reason that we needed to put using namespace std at the top of our other program, because we're trying to refer to a name that is defined in std as part of a function declaration. So as I told you then, you can also do it this way. Use the namespace and the scope resolution operator right with that. Of course, if you're going to use those names somewhere else, like cout or whatever, you're still going to need either using namespace or you're going to have to put the namespace by each one. And in fact, that's what's happening here. These are actually constants that are defined in the iOS namespace, and they've just prefixed those names with them, which it just looked like gobbledygook before, but it's really not. Now, that may seem like a lot of work to be able to get rid of this line of code, but there are cases where that would be important when you're trying to avoid mixing up colliding identifiers from different namespaces. You know, and as long as we're only using the STD namespace, it seems fairly straightforward. But I've looked in programs that used quite a few different namespaces, and it can get ugly. So there are programmers that use this notation every time they refer to anything that's in a namespace other than the global namespace. So you may find it both ways.
Is NDL and the Netherlands science standard?
I'm sorry?
NDL,
NDL.
or ENDL, excuse me.
Oh, ENDL. ENDL, I believe, is defined in the STD namespace as part of IOStream or FStream,
Okay, but it wouldn't be.
which is why we haven't been using STD in front of it, because we're already using namespace STD. Otherwise, I would have to say
Yeah, I ran into that. But I just made a guess that it was there, it was.
okay. All right, page 337. Ms. Hernandez, here is another piece of code, and they've got the data in a file, and they want to know what would be the output. All right, 1. Two. Three. Is that it? What does this line do? All right, we're incrementing right here. So we start with 0. We say 1, and we output the first item, which is 1. So we add 1, we get 2. We output the second item, which is 2. 3, we output the next item, which is 3. And then we do a get. And I got so busy talking about the code that I skipped over the part where we can determine the end of file. So you'll notice that this extraction operation takes place inside a place where we're expecting a Boolean value. So what happens when we're doing an extraction is that extraction actually returns a Boolean value that indicates the status of the end of file. So as long as the extraction worked and we got valid data, we'll get a true. A true means that we haven't reached the end of file yet. If we try to extract data and we can't get any data, that means that we've hit the end of file, we've gotten the last data that we could, it will return a false, and your variable or your buffer that you were reading into is not going to have valid data in it, so you don't want to use it. So this is a useful way of getting data from a file into a variable and stopping when we run out of data. So since we read 3 and then we tried to read again, there's no more numbers in this file. We're going to get a false here. We're going to go down here, we counted to 3, and we're going to output 3 again because that's what's going to be in count at that point. Okay? Mr. Brantley, number 20 wants us to write a toScreen function with a formal parameter called FileStream of type ifstream. And here is the pre and post condition for that function. Can you write that function definition for us?
Okay, so void space file.
We need
I'm sorry, it'd be ifstream and then file.
ampersand because it has to be a reference parameter. Okay?
So the precondition, would that be assuming that the file is already connected?
Yeah. So whatever stream that gets passed to us has already been opened. And our job is to read the contents, which is a list of integers, and print them out one per line.
I'm not exactly sure because I'm assuming the file's already been called. So in the function, would you need to do the whole ifstream?
We're being passed a reference to an IF stream in the variable file stream.
So it would be similar to the last one. We would say while parentheses greater than. Next, I'm not exactly
Okay,
sure.
we're going to be getting a list of integers, so we need a place to put it. Basically, that's it. So we've got a file stream that's been connected to a external file with open. We're going to get data from it. We're going to store it temporarily in an integer called next. We know if we get true here, we got data, so we can output it. It said 1 per line, so I need to put an end line here. And that's it. All right. So far, we've been using the extraction operator to get all our input for us. And we've been using the insertion operator to send all our output out for us. But there are more granular ways to do that. And one of those is with the get and put functions. Get allows us to retrieve a single character at a time. And put is a corresponding function that allows us to output a single character at a time. We could already do that, but they wanted to have a symmetrical set of functions. So what distinguishes get from the extraction operator is that it will get every character in our input stream. It is not limited to numbers or characters. It can get white space, including new lines and so forth. So they've used that in this program called checking input, display 6.7. I would say they haven't used it to its fullest effect because they're still just getting an integer using the extraction operator and then using new line to skip any white space and throw it away until they get to a new line character. There's also a function called putback, which basically stuffs a character back into the input stream so that the next time you do a get on it, it will get that character instead of the next one. So if you got one too many, you can stuff one back in so that it won't mess up your code. So get allows you to retrieve one character at a time, which means you're going to have to be a little more careful about how you deal with those characters. For example, on the bottom of page 345, they show you something interesting that can happen if you mix get and extraction. So here it says, enter a number, now enter a letter. And they use the extraction operator, you get the number, and they use the get operation to get the letter. So on the next page, we enter some data, 21 and A, and you might expect that number will now have 21 in it, and symbol will have the letter A, but it doesn't. Symbol is actually going to have a new line in it because the extraction operator stops whenever it sees white space. So it's going to find the 2 and the 1. It sees the new line as a white space, so it stops, and its little pointer is pointing to the next thing in the input stream. When I typed the input stream, I typed a 21 and an enter, and then an A and an enter. So it got the 2 and the 1, and now it's pointing right here. When I come down here and do my get, the very next thing in the buffer that I'm pointing to is going to be that new line after the 21. And that's what's going to go into that character. So there's a couple of ways around that. One way would be, well, continue to use, if you don't need new lines and white space and worry about where they are, you can use the extraction function, the extraction operation. Otherwise, you're going to have to handle extra new lines or whatever. For example, using that new line function that we saw in display 6.7. They went ahead and made another new line function that can be used with any input stream. You'll notice this is IS stream rather than iStream instead of IF stream. iStream is the class that CN is in, or CN is an object of the class iStream. And IF stream is actually a subclass of iStream, or a child class of iStream, which means that it inherits anything that's in iStream. So anything that's defined as an iStream can be used with an iStream, the parent class, or any of its child classes, because it's not expecting to be any more specialized than the parent class. Which means that we can use this new line function with either an input file, FN, for example, or CN, the standard input stream. And if you go on to the next page, you can go one more step further. And we can give our new line function a default argument. That's this part right here. An equal sign and the default value. And now we can call the new line function the way we did to begin with no arguments. Or we can give it a specific argument and it will continue to work. If you're going to use default arguments, they have to be the last arguments in the list. So you'll notice this function has 4 parameters. 1, 2, 3, 4. The first 2 do not have default arguments. The last 2 do. So we can call our function with 2 arguments, and it will use the default values for the other 2. Or we can call it with 3 arguments, and it will use the default argument for the last one. Or we can call it with 4 arguments. And we supply all of the values. But we can't skip any arguments, and we have to have at least 2 because those first 2 don't have defaults. All right, so we have a variable C of type character. What's the difference between those 2 statements on 22, Mr. Gear?
C is going to get user input and it's going to get it from the file.
No? CN is the same in both cases. CN is the standard input stream. What's the difference between the extraction and the get function?
Extraction, we get the next letter, we get the next symbol, white space, inline.
The extraction operator is always going to skip white space. So if the next thing in your buffer is some kind of white space, it's going to skip over it and find the next letter, whether that's a digit or a alphabetic character or a plus sign or whatever. It's going to skip any white space that it finds. Get is not going to skip anything. It's just going to give you the very next character in your input stream no matter what it is, including spaces, tabs, new lines, or any other kind of white space we might come across. All right, Mr. Nelson, number 23, what's the difference between the insertion and the put operation? Nothing. They do the exact same thing. We could always put our send white space to our output stream. If that's what's in the character, that's what's going to be sent out. Put is just a corresponding function to go with the get. All right, let's go on to the EOF member function. So we talked about putting our extraction operation in where we're expecting a Boolean and using that to detect when we've hit the end of file. That's all well and good as long as we're using the extraction operation. But what if we are getting one character at a time and we still need to be able to detect the end of file? Well, luckily there is a separate function called EOF that tells us when we get the end of file. And this is one of the few cases where we recommend that you use the not Boolean operation, because EOF returns a true only if we have already gotten the last character of the file and we tried to read another character. And while is only going to keep going while something is true. Since EOF is mostly going to tell us false until we get to the end of the file, we need the opposite of that. So while not EOF. And you'll also notice that we do a get before we call our while function, or before we start our while function. This is what's known as a priming read. We need to do one read before we start our loop, because otherwise we have no way of knowing if we had an empty file, which is what would happen. If we have an empty file, we would immediately not have any data to get, which would mean end of file would be true, which would mean we need to skip this whole business and stop. But EOF is not going to be true until we have read the last character in the file and we tried to read another character. So let's look at more self-test exercises on page 355. Where did I leave off? Was that Mr. Rahim? Suppose INS is a file input stream connected to a file, and you just read the last character in the file. Would EOF be true or false? So here's our file. It's got A, B, and C in it. The last character in that file is a C. We just read the C. Is EOF true or false?
False.
All right. Does that make sense to everybody? I read something, I get the A, that's my first read. I store that in my read buffer. The next thing I'm going to read is there. I'm not at end of file yet. I read again. I get the B. I'm still not at end of file. I do a read again. I get the C. I'm still not at end of file because I'm still getting valid data, right? Now I do one more read. I don't get something new. This is typically what happens. I don't get something new. If I try to use that data, I'll get duplicate data. Now, some systems may give you garbage, but what I've seen happen is your buffer still has the same old data in it. But EOF is true now, which means this data is not valid. I should not be using it. EOF is true. That makes sense, everybody?
So how would you not use that data?
Well, you would not use that data by constructing your loop properly. So when we were constructing our loop, we did a read first, and then we tested EOF. Every time we do a read, the very next thing we have to do is test for EOF. And that way we don't use that data. All right, another thing that's going to be useful when you're using GET and you're processing data one character at a time are some predefined character functions. They list some of them on page 359. These are also in Appendix 4. Some library functions under character functions, page 1022. Two upper and two lower return the ASCII code of the equivalent value in two upper is going to return the ASCII value of the uppercase as an integer, actually. In fact, I prefer that you read the chart in Appendix 4 because it's actually a better chart. 1022. So two upper, two lower. You'll notice the data type that it returns is integer. It's not returning a character even. Who knows why they did it that way, but they did. So if you are storing it in a character, because character is just a small integer internally, it's probably not even going to give you an error message. But if you're trying to output the results, then it's going to be outputting a number instead of a character. So you want to be aware of that. The rest of these are all Booleans that will tell you what kind of character data you have. So is alnum alphanumeric? Is alpha A through Z, either upper or lowercase? Is digit 0 through 9? Is punct a printable character that is not alphanumeric and not white space?
So we could use those operators to, instead of the way we've been doing, like yes and no, and then Y, capital Y.
Sure. Or you could just say to lower and then test for lowercase y.
Right.
So yeah, you can use those. So these are all going to be useful characters or useful functions whenever you're manipulating character data. All right, a little bit more self-test exercises. Ms. Hernandez, we have some code, and they want to know what the next line of output will be if I type in this text, "I'll see you at 10:30 a.m." So we are doing a get next, processing one character at a time. So we're going to get each character one at a time and output it I. And then we're going to test while not is digit next and next not equal new line. So is I a digit? No. Is it a new line? No. So we keep going. We get the next thing. That's not a digit or a new line. And then we'll keep going. So we're going to keep going until we get to the 1. So I'll see you at 1. Since we get it and output it before we test it, we don't find out that it's a digit until here, and then we finally say end of output right there. Does that make sense? All right, let's look at our programming project for this week. It will be number 10 on page 373. Assignment 6, baby names. The text file baby names 2012.txt, which is not only included in the source code for the book and is available online, it's also in the online classroom. I'll show it to you in a minute. Contains a list of the 1,000 most popular boy and girl names in the United States for the year 2012 as compiled by Social Security. A space delimited file of 1,000 entries with the rank first, followed by a boy name, followed by a girl name for each line. Okay, so Jacob is the #1 ranked boy name for 2012. Sophia is the #1 ranked girl name for 2012. So your program needs to allow a user to input a name, read through the file, looking for a matching name among boys and girls. There are 3 possibilities. It may have a rank for both boys and girls. That's one possibility. It may have a rank for either boys or girls, but not the other. And it may not have a rank for either boys or girls. So if it finds it for both boys and girls, you're going to have two lines, one with the rank for boys and one with the rank for girls. If it finds it for one and not the other, you're going to have one line for the rank for the gender it found it for, and one that says not ranked amongst the other gender. And if it didn't find it for either, you'll have two lines that both say not ranked, one for girls and one for boys. Remember, if you want to reread a file from the beginning, you must first close it, then clear it, and then open it again. So, F-stream, IO-stream, C standard line, that all looks good. And we can either put using namespace there or the book's preferred place here. And depending on if we need additional functions or not. We're going to take our input from a file and we're going to output to the screen, right? I told you that the file is available on our website. So let's go find that. In the general course documents, baby names 2012. If you click on it, it just shows it to you, but way down at the bottom, there's a download button. And it went wherever those things go, so I'm going to save it to my project folder, where my source code file is. So there it is. What file are we opening?
Baby names 2012, and I just clicked out.
.txt. I don't have an output file, so I can get rid of that part. Let's see. I don't want to just do this once and stop, because what if I want to find out if another baby name is popular? So let's put this in a loop. So I can either end it by asking if I want to keep going, or I could end it by using a flag of some kind. And compare the two lower of that answer to the lowercase y. I also said we had to clear the file. Make sure that it actually starts over at the beginning. All right, so here's where the interesting part goes. What do I need to do here?
Ask for the baby's name.
Okay,
So CO. Their baby's name. We need to get a string.
okay.
So you need to add a string.
So what do you want to do?
We want to get it.
Well, in this particular case, all of the names are like well-formed strings without any embedded spaces, and the file itself is space delimited.
So we don't need white space.
So theoretically, we would be safe. If you want to make your program more bulletproof, you could add more stuff to it, although we haven't really learned how to manipulate strings yet. So that's a question. So for now, I'm just going to say we'll allow the prettiness of the data to protect us from errors of that kind. All right? So we've got a name. We want to search for it. What do we need to do now? Ms. Hargrove, any ideas? Mr. Nelson?
You need to compare what was entered with boys and girls' names in the file.
Okay.
So
How are we going to do that? Anybody? So we've got a name. We want to compare it to the names that are in the file. In order to look at something that's in the file, what are we going to need to do? We're going to need to read data out of the file. How do we read data out of a file? So here's the file. This is what it looks like. I've got all this data. Yes?
Get characters from the file.
All right. So we could get characters from the file. If we get characters from the file, how are we going to compare them to our name?
While loop in need space or white space.
File what?
search the file for free? Or is that-
Well, to search the file would require a function that reads the file and looks for particular strings. And there's no standard function available to do that for us. So we're going to need to read the file ourselves, read the data out of the file, and store it in a variable, right? So the data looks like this. The first thing we're going to get if we start reading the file is what?
1.
1. What is 1? An integer.
The integer rank.
An integer, that's the rank. So what are we going to do with it?
We're going to store that as an integer.
Okay. So how do we do that?
Make it in rank.
Int rank. All right, so we have an integer called rank.
And then we're going to do, can we do the EOF not true? To read the
Well,
whole thing? Or
we
do
could.
stop?
But again, I mean, we're trying to do something that's fairly simple here. This file is well formatted. We know that it has a number and 2 names, all separated by spaces on each line. So what I'm going to tell you can do is we can read from the file into rank and use that as our controlling expression for the loop. Because once we try to read a number on a new line and we don't get one, our file is over, right? Each line is going to have a rank, a boy name, and a girl name on it. So okay, so there's that. What does that give us?
Variable to store the name.
Yes. And what do those variables have in them?
Jacob and Sophia right now.
Jacob and Sophia. We have 1 in rank, Jacob in boy name, and Sophia in girl name, because we've read the first record. So each time through this loop, we're going to have 1 line of this file with a rank, a boy name, and a girl name. So what can we do if we have a rank, a boy name, and a girl name?
Compare them
We can compare
with the CDN review.
if name is equal to boy name. What are we supposed to output? Boy name is ranked, rank, and popularity or among boys. All right, if that's correct, this code should actually run right now. won't do everything it's supposed to, but it should run, right? So let's give it a shot. So what name do you want to search for? Bill. I don't think it found a Bill. Let's search for one we know is in there.
D'Angelo.
Huh?
D'Angelo.
D'Angelo, like that.
That's what it says.
Oh, look, it's ranked 869. All right, make sense? We know what we're doing now? You think you can finish this?
How's it differentiating just the boy's name and girl's name, just the word that you put it there? But the word that you're calling it?
It's reading them into the variables. So the first one it's going to read into the boy name. That's the first one on the line. And the second one is going to read into girl name. That's the way it distinguishes.
So if we try a girl name, it'll still read out, right? Without needing to input the,
No, because it's not.
Yes, you're going to have to compare it to both names. So right now we're just comparing it to boy name. We'll also have to compare it to girl name. And you'll also have to figure out how to tell me that it couldn't find a boy name or a girl name or both.
So-
Okay?
How did it grab the whole name and not just a character, just by using the element?
Because I'm using an extraction operation into a string variable. And it's going to keep going until it hits a white space.
And why did we not have to tell it to not check the white space? Because I thought in the other practices we had to write it out.
Extraction will always skip over white space and stop when it gets to white space. That's the way the extraction operator works. If we were doing a get, we would have to get every character and test for a white space. But the extraction operator is already doing that, is really what's happening. And assembling a string for us. Any other questions?
If we were using the get, because like what you said, I mean, some names have white space in them.
Okay, yes.
How would it differentiate that being the same name?
You would have to figure out how to do that. Probably you would need to use something else to act as a delimiter. So, for example, if this was a database, I would probably put everything in double quotes and use double quotes as my delimiter character. Or we could separate them with commas. And then you would have to search for a comma.
So you wouldn't do it by doing white
But
space.
if all you've got is white space, it's going to be very difficult to tell one white space from another.
Right.
Which is why they did it this way, because it makes it an easier assignment. All right, everybody know what they're doing? And this will be due next week. We'll have a quiz over chapter 6 next week. And we will also, I believe, be reviewing for the midterm exam next week. We will also,
So midterm.
we can also talk about homework. I think I'll actually extend the due date to the 15th so that you don't have to. So if you come up with questions, we'll have time to talk about those next week.
So the names aren't due until the 15th.
The names will not be due until the 15th instead of the 8th. Okay?
So we're taking a quiz on the
We will be taking a quiz over chapter 6 on the 8th. Yes.
Is the midterm the week after next?
Yes. Midterm week after next. Quiz next week. We can talk about homework. We'll review for chapters for the midterm, and then midterm exam the following week.
I have a question on this most recent homework assignment.
Okay.
It's actually for any of them.
All right.
Because I never noticed this until the night when I was playing with it. I accidentally hit YY
Okay.
when I was asking if I wanted to do it again, and they just went,
Yes.
right. How can I limit that to one character?
Why?
I remember on like all the old DOS programs I used to play with when I was a kid, you'd hit Y and it would automatically do that.
So using input streams, that data gets buffered and it doesn't send it to your program until you hit return. So you would have to use basically raw input and do all that processing yourself. It would add a lot of code to your program to do that. But I can point you towards some libraries that do that if you want.
Okay, well, I mean, I just don't want it to, because it got stuck in a.
Yeah.
a loop.
So if all you're concerned about is getting stuck in a loop, then you can process that with a get and throw away any extra characters that get put in.
Right.
But get one character at a time. The next thing has to be a character, so you're never going to have a problem with that. It just won't come into your program until you actually hit an enter. Unless you're using raw input.
I've also been using Boolean statements for that instead of the do while,
Uh-huh.
because it's easier for me to deal with incorrect input.
Okay.
Because then I can do, I don't know if you created the blackjack program, but I do that also.
Yeah, I don't think I have yet. Sorry.
But basically what I've been doing is a while statement, more change was this last one.